we want to expand a logarithmic expression, and in problem type 2 we are given bigger expressions to deal with, and we need to remember about the relationship between radicals and exponents as well. Remember that a square root is the same thing as an exponent of 1/2. So the first thing I'm going to do is get rid of the square root by using the exponent 1/2. So I have the log base 10, the square root of x y to the 9th over z to the 4th. That is equal to the log of x to the 1/2 y to the 9/2 z squared in the denominator. And now I will use my properties to take these apart. This is the log of x to the 1/2 y to the 9/2 minus the log of z squared. And then I can further take this apart using addition. This is log of x to the 1/2 plus the log of y to the 9/2 minus the log of z squared. And then I take all the exponents out front as coefficients. So this is 1/2 log of x plus 9/2 log y, and then minus 2 log z. I'll do another example for you, and I'm going to start just by writing the answer. This is going to be 5 times the log of z plus 5/3 times the log of x plus 2 minus 1/3 log of y. So I took the expression, and everything that's multiplied is positive, everything that's divided is negative, and I just pulled the exponents out front all in one step. So here's my 5 log of z. That is multiplied times x plus 2 to the 5/3 and divided by, so that's subtraction, y to the 1/3. Now I'll show it step by step. This is the log of z to the 5th, x plus 2 to the 5/3. Actually, I should put parentheses around the whole thing, over y to the 1/3. And you have to be very careful about what's actually under the radical and what isn't. Y is under the radical. This is the log of z to the 5th plus the log of x plus 2 to the 5/3 minus the log of y to the 1/3. And when I pull the exponents out front as coefficients, that leaves me with 5 log z plus 5/3 log x plus 2 minus 1/3 log of y. And that is the answer I have right here.